And now we begin the last section of Chapter 2 in AB.
Now we're on Schoology, every single grade, and that's the story of the evolution of Wade.
And now we begin the last section in Chapter 2 for AB. And first, some review from Pre-Calculus and Integrated 3. Do you remember these goodies right here? First of all, natural log of 9 is equivalent to something else. What's so special about 9? Hopefully any student who's ever had Mr. Wade's class is like, oh my gosh, 9, it's a perfect square, right? Natural log of 3 squared. And there's something special that can happen only in log world. It works for the natural log, it works for the regular log log, it works for all the logs. The exponent can also be written as the coefficient in front. 2 times natural log of 3. You don't even need the parentheses anymore. And only for log problems is the exponent the same thing as the coefficient down in front. They're interchangeable. Nowhere else in math would that ever be possible. Okay? So remember that. You're going to need that technique today. Now, what about natural log of e to the x? All right. This is a big key from Integrated 3 and Pre-Calculus. The natural log of e to the anything should be able to cancel the natural log and the e. All right? Why? Same reason as this 2 moving to the front. Can't we just move the x to the front because we're in log world? Isn't that just x natural log of e, right? That's allowed. But wait, the natural log of e is 1. That's one of our 2 natural logs we're supposed to know. The natural log of e is 1, and x times 1 is just x. So this is a very special case. This is the general case. This is a specific case. Natural log of e will just cancel both of those, and you get whatever the exponent is. You can always do that in a math class. We're going to do a ton of that this year, by the way. A lot of natural log canceling e. Okay. Absolute value of x is less than 10 can also be written as something else. All right. Let's see. What things have an absolute value less than 10? The absolute value of 9 is 9. That's less than 10. Yeah. The absolute value of 8 is 8. That's less than 10. Okay, yeah. 7, 6, 5, 4, 3, 2, 1, 0. Those are all okay. I wonder if -1 satisfies this inequality right here. The absolute value of -1 is +1. Still less than 10, yeah. So it sounds like we can use numbers all the way from 9 all the way down to even -9. Now what if we went to like -11? The absolute value of -11 is +11, which is not less than 10. So -11 is too far. +11 is also too far. That absolute value is not below 10. So it sounds like we're kind of sticking between maybe 10 and -10. Okay, here's another way to write this. X must be less than 10, all right? Not even 10 is okay because the absolute value of 10 is 10, but 10 is not less than itself. That's why we don't underline it over here. We're saying, no, I don't want to count 10 as an answer. But everything below it, 9, you're fine. 8, you're fine. 9.99, you're okay as well. You just can't choose 10 or 11 or 12 or 13. Now let's talk about the other end though. What about the lower end? You can't choose, we said -11 was bad. What about -10? -10, absolute value turns it to +10, which is not less than itself. So even -10 fails, -11 fails, -9's okay, -9.99 is okay, but -10 is the barrier at the other end, okay? What this means, this expression in calculus means, and even like in integrated classes, what this expression means is that we're only talking about the x values that are ranging from -10 to +10, but not including -10 or 10, okay? All the numbers between those two. Now, hopefully, since I went through all those numeric examples, that makes sense that this is just a whole window from negative 10 to positive 10, but not underlined, not including negative 10 and positive 10, and not including anything outside of that. Okay? You need to know that today. Now, let's go over here. 3 times natural log of x. In log world, which this problem is in log world, you're allowed to write 3 as a power instead of a coefficient. We can put the 3 up on top of the x, as long as you cube the x, not the entire natural log. There are optional parentheses. You don't have to put those, but you can. Let's circle this one too. So you can put parentheses. The cube is not on the whole problem, just on the x. Okay? And finally, you'll need to know this today. Natural log of e is the one case that cancels. The second case that cancels is e to the natural log. It's got to be to the. We did this all the time in integrated 3, using e to cancel natural log. E and natural log will cancel, and you're left with the 5. Okay? So we saw the 2 cases where they cancel each other. We saw cases where coefficient and exponent mean the same thing. And then we saw this special notation right here. Now you're ready to jump into this chapter. All right? Good to always have a refresher, especially during a pandemic, right? And back over here for question A, we have the derivative of y equals e to the natural log of x squared. Okay, in this chapter, we've talked about exponential derivatives. When the variable x is up there in the exponent, remember we have that new exponential rule, right? Keep it the same, natural log of the base, chain rule, we've been talking about that. Okay, this is not an exponential function though. It's just a regular, ordinary parabola in disguise. So here's what you don't want to do. You don't want to just jump into the derivative and not think, wait, I probably should have simplified before I did the derivative. Okay? E to the natural log cancels. It's one of our special cases that cancels over on the other board there. And you just get x squared. This is just y equals x squared. How easy is it to take the derivative, but you've got to be paying attention and simplify when you can simplify. Okay? Now, let's take the derivative. Let me change this to red. Oh, there we go. Y prime equals 2 comes down, x to the first power. Done. How easy is that? Just pay attention, right? Okay? Now for letter B, take the derivative of y equals e to the 4 natural log of x cubed. Hey, e to the natural log is supposed to cancel, right? And right here, I've got e to the natural log. Oh, nuts. Somebody put a 4 in there. Well, Mr. Wade put the 4 in there, actually. I put a 4 in there. The e to the natural log can't cancel because the 4 is between them, holding them apart. Boy, I wish that e could get right next to that natural log. I wish that 4 wasn't there. Wait a minute. Stop wishing that 4 wasn't there. Just take it and store it up in the attic. Because remember, let's pull this over here as an aside. Let's just look at the exponent of this problem, which is 4 natural log of x cubed. Didn't we say that coefficients can also be written as powers? They're interchangeable, right? So this is natural log of x cubed to the 4th. Can't you just store the power up there and get it out of the way? Now you have to be careful here. What's going to the 4th power? Because mathematically there's only one correct answer. It's not the whole thing. The whole thing is not going to the 4th power, okay? It's not the 3. The 3 is not going to the 4th either. It's the contents of the natural log. What were you taking the natural log of? X cubed. Well, then that's the thing that gets the 4th power when you put it up there, okay? So just that. Now, do you remember in middle school, a power to a power, you multiply the power? It's not 4 plus 3 is 7, right? It's 3 times 4 is 12. Natural log of x to the 12th, okay? So, back over to our problem now. Before you take the derivative, do some rewriting and make it easier for yourself. E to the, this box is going to be changed into this, natural log of x to the 12th. Okay. Parentheses optional, you can put them if you want to. Do you see how we took the 4 and we stored it up out of the way? Now the 4 is not in the way. Now they're next to each other. Now you can cancel them out. That is straight out of integrated 3 and pre-calculus right there. And you get x to the 12th. Now don't forget something. You've done a lot of great integrated 3. Congratulations, that's 2 years ago, or for some of you last year. But wait, we didn't take the derivative yet. Don't do all the old math and then don't do the new math called calculus. You still have to take the derivative, so just don't forget. There's your new function. How easy is it to say y prime equals 12x to the 11th, right? And there's your final answer right there. Over here for letter C, we have g of x equals natural log of square root of 36 minus x squared. All right, well, let's start right off the bat. You know when you see a radical in this class, you've got to change it into exponent form. So we've got to do 36 minus x squared. Do you all remember that square root means 1/2 power? Okay, do that first. All right, now, we did learn a natural log rule at the beginning of this chapter. There is a derivative rule for natural log. You could put 1 over all this stuff, and then you have to do the chain rule derivative of all this stuff over here. Oh, that gets really messy, really, really messy. Okay, I want to show you something, all right? It is always easier to take the derivative of a natural log with this number down here as a coefficient as opposed to as a power. 100% of the time, it's easier down here. Now, it's your choice. You could do the derivative of this current form right here, but I'm telling you, it is messy and students never simplify it correctly because it's such a mess. You're going to make it harder on yourself, okay? So I have an idea. Before we take the derivative, let's realize that we're in log world, and the 1/2 up here could also be written as the 1/2 down there. All we just did was integrated 3. We haven't even done any calculus yet, okay? That is going to be easier than this. Now take the derivative, okay? G prime of x equals, now how do you take the derivative? All right, we've seen this a couple of times where we had a coefficient. Just remember, when you take a derivative, the coefficients always stay right there. Just keep your coefficients. It's 1/2 times whatever we get from over here. What's the rule for the derivative of natural log of 36 minus x squared? 1 over base times, it's automatic, right? Chain rule or derivative of the original base. Derivative of 36 is 0 minus, so let's just put minus and drop the 0. Minus 2 comes down, x to the first. Okay? There's your derivative. So much easier, way harder form. You want to do the easier form. Okay? And now that's over 1 technically, if that helps you. I got all my fraction bars. Well, I didn't quite line that. I should have lined that one up a little bit better. This is multiplication. This is multiplication. It's all multiplication. I can cross cancel this -2 with that +2 right here because it's all multiplication. -2 over 2 is -1 with this x, of course, over 1. So that's just -x. I would definitely do that. So, final answer. On the tops, 1 times 1 times -x is -x in the numerator. 1 times 1 times this is this. There's your answer right there. And for you overachievers, they sometimes put this on the multiple choice for the AP test. Doesn't this kind of look backwards right here? And doesn't this look negative right here? Well, it is. Well, there's something you can do. If you factor a negative out of the denominator, let's take out a -1. If you take out a -1, -1 times -36 is 36. -1 times +x squared is -x squared. okay? If you factor in -1 ever in any place in math, it just changes positives to negatives and negatives to positives. Let me show you the advantage. If you take the -1 out, the negative and the negative will cancel each other. And you get positive x on the top. And on the bottom, you get -36 plus x squared, which is better written as x squared first and the -36 last. You see how much prettier this one looks over here, right? Than this one with its negative over backwards. So if you ever see in math a negative over a backwards binomial, you can do forwards binomial and positive, and two lefts make a right, or two wrongs make a right. No, you don't want to say that, no. Two negatives make a positive, okay? So often on the AP test, they'll put this answer. It's okay if you leave this on one of my tests. Just be able to adjust and look at your answer on the AP exam and say, oh, that's the same thing. Because they didn't put this, they put this instead. All right? Just in case, just in case. Now, if you notice, when I got our final answers here, either one of these being acceptable, I never did mention this thing right here because we didn't even use it because you don't need to. All right? The stipulation on the side was that the absolute value of x is less than 6. What are they even talking about if they put that there? So I chose to put that there on purpose. Remember the warm-up? Doesn't that mean that all x's that are less than 6 but simultaneously greater than -6 satisfy this inequality? Isn't that what that means? So this is what they're telling you. They're telling you that this function only exists between -6 and +6. So they do have to put that stipulation legally on the AP exam. Don't worry about it. I'll put it there just for practice on our chapter test and our sample test. But don't worry about it, okay? But what it's saying is, this function, you can't step outside of 6 or -6. What if I go to 7? What's wrong with going to 7? Why is that bad? If you plug in 7, 7 squared is 49. 36 minus 49 is a negative number. You can't do the square root of a negative number. Aha! That's why I'm trying to protect you from 7 and 8 and 9 and 10. Now, I wonder why this isn't underlined. I wonder why even 6 is bad, right? X can't be 6. 6 is not less than itself. Why is 6 bad? If you plug in 6, you get 36. 36 minus 36 is 0. You can take the square root of 0. The square root of 0 is 0. So what's up, Mr. Wade? What's up with that? But then you have the natural log that you have to apply to it. The natural log of 0 now is impossible. Does not exist. Because remember, you can only do the natural log of a positive number and never of 0 or negatives. So that's why I was trying to protect you from 6 and also -6. Squared is positive 36. You get the same problem. Square root of 0 is possible, but natural log of 0 is impossible. All right? So if you see this in the future, just say to yourself, oh, the derivative doesn't exist outside that boundary. And if they don't legally put this on the AP test, you could say, well, the problem's invalid. I can't take the derivative of what doesn't exist. So I'm telling you, only focus on where it does exist. Okay? That's the whole story there. And now we do the final problem, D, where we have an interesting riddle. G of x is equal to something. G prime of 9 equals 30. It's the first time I've actually given you what the derivative is, or what the slope is, let's say. Or maybe this is the rate at which a possum population or a rabbit population is increasing. Remember that? So, the derivative at 9 is 30. All right? A scientist could use this. 9 years into our study, the growth rate was 30 salamanders per year, or whatever we're studying here, right? Go find k in the original function to make this work. Interesting. All right. So let's see if we can do it kind of backwards. If I give you the derivative, you give me the k value. Well, first of all, we need to take the derivative, right? Because it says g prime. That's a hint. So we need to get to derivative world. Okay. Oh, it's a natural log. We have rules for taking the derivative of a natural log. But wait a minute. If you jump into the derivative, you're going to cause yourself unnecessary chaos. couldn't we relocate that k in front? Didn't I just say what I just tell you over there? If you take a power and you write it in front, only for log world, right? Only for log world does this work. Isn't it easier to have the coefficient than to have the power, right? And guess what? We have the power to do that, no pun intended. Actually, pun intended. In Mr. Wade's class, always. Put the k in front of the natural log of 3x minus 1. That's not a derivative, by the way. I know it feels like we're bringing stuff down and it's a derivative. That's where students get confused. That's just integrated 3. K up there as a power is the same as k down there as a coefficient. So only using our integrated 3 skills. Now let's do the calculus. We need to get to g prime. G prime of x is, k is a number, by the way. That's k times natural log. If you see k or c anywhere in this class, just pretend like it's 7 or 16 or whatever your favorite number is. It's just a constant. It's just a coefficient. It's just a number. When you take the derivative, don't you remember that constants or coefficients carry? They stay. Times, now let's focus on this. What's the derivative of natural log of 3x minus 1? 1 over the base times the derivative of the base, the original chain rule, right? The derivative of 3x minus 1 is 3 minus 0, so times 3, okay? All right, k's over 1, 3's over 1. If you don't need that, don't put it. If you need it for a security blanket, put it over 1. Look at the numerator. K times 1 times 3, 3k. By the way, see how easy that derivative was when we relocated the k down in front? 1 times 3x minus 1 times 1 is 3x minus 1. Okay, there's your derivative. Your derivative is done. Now, clue, g prime of 9. When I stuff 9 into the derivative, I should come out with 30. Okay, that's what that says in English. When I stuff 9 in for x, of course, plug it in as an x coordinate. There's no such thing as a k coordinate. K is just a number. When you plug 9 in for x, the outcome, the output, the result shall be equal to 30. You can now solve a middle school level equation because you've done the high school and college math already. Now, 3 times 9 is 27. 27 minus 1 is 26. 3k over 26 equals 30. Now, I want to train you to do something right here. I know a lot of you are probably thinking, hey, I want to get rid of that divide by 26, so I'll just multiply 26 up to the other side. I'm in no mood to do 26 times 30, okay? Ugh. All right, what you should be doing is this. Could you multiply the 26 and then divide both sides by 3? Yeah, you could, but back in integrated 3, we did all that in one step back in my class. I bet you remember. If you had me for integrated 2, we even did it in that class. What is the instantaneous way to get rid of 3/26? Because that is your coefficient. Do you remember multiply by the reciprocal if you took my class before? Multiply both sides by the reciprocal, 26 over 3. That is so much more practical. Because a reciprocal will cancel its reciprocal instantly. K's by itself. You just got k solved. If we could just solve this over here, we're done. K equals what? So everybody see that reciprocal trick right there? All right, we did that a bunch in integrated 3. All right, now, don't do 30 times 26. That's 30 over 1. It gives us the cross cancel when you do my reciprocal trick. You get the cross cancel available to you now. I don't care what 30 times 26 is. 30 over 3 is 10, or 10 over 1. And now you've got 10 times 26 over 1. 10 times 26 is a lot easier. It's 260. You see that? You see, my friends, reciprocals pay off, and cross cancellation also pays off. That's why I taught it to you if you had my class over and over and over again. All right? There's your final answer. So go work on your sample test, and we'll discuss it next time in class.